All right, some of y'all are starting chapter 7, so let's see how technology can help us out in chapter 7. Um, so, if we're looking for an area underneath the normal curve, a lot of times in the beginning they're giving us z values. And to find a z value, you take your x, your variable, minus the mean, the population mean divided by the population standard deviation. And so you'll be asked to calculate some z-scores, but then if you want to find combined area, this one's going from -3 to 3. Now we know that should be around 99.7% because of the empirical rule. But if we go to stat and then calculator, in chapter 6 we went to the binomial calculator, but now we're just going to go to the normal calculator. And for a z-score, the mean is 0 and the standard deviation is 1. So that's just for z-scores. And it's set up for z-scores. So if I want to do a between -3 and +3, it will find an answer for me. And again, 99.7% based off the empirical rule. We could change this however we wanted to, and it will give us the picture, it will tell us the area. If we look in between ±2 standard deviations, again it should be 95 based off the empirical rule. But now I can look at different values that the empirical rule did not give us, and we'll find the area in between the curve. Now, there's been a couple questions out there on how do you find the middle 68%, the cutoffs. So to find the z-scores for the middle 60%, let's think of it a couple ways. If my middle, right, is 60% and it's in the middle, that means it would be symmetric on both sides. So let's just pretend this is symmetric on both sides. That means there'd be the same amount to the left and the same amount to the right. So if I have 60% here, then that means in these pieces I have a total of 40%. The middle is 60%, so that means 20% should be over here and 20% should be over here. So we can find those z-scores by plugging in a percentage. If I want to find where 20% is to the left, I actually type in my 20% over here. In the calculator, it has directions for finding the inverse norm, and so that's what I'll call this. We are finding the z-score based off of an area underneath the curve. So again, this would be, so this is about -0.8416, and we'll verify this by looking over here. -0.8416, and then +0.8416. And that should give me about 60%. That's my middle 60%, and I have 20% to the left and 20% to the right. So I hope that helps with that question. There's also, you're going to have questions in here that you're going to use our calculator, and they'll give us the mean, they'll give us the standard deviation. Like if you look at IQs, the mean IQ for someone is 100 with a standard deviation of 15. And so if I scored 110 on the IQ test, this will tell me how many people I did better than that took the test. 74%. If I go to the right, that tells me how many people scored better than me. 25%. Right? So we can control that. If I put between, I could say how many people scored between an 80 and a 135. Right? And it'll compute that area, the percentage of the population, and also give us a nice picture. I like StatCrunch. So I hope that helps with ideas in section 2 of chapter 7.